Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. And joining me tonight, we got Nathan. And I'm going to get Lulu here in a second. It is Saturday night. It's the 14th of December. And Christmas just around the corner.
Yeah.
Is everybody ready?
Yeah. I hope so, man. I got so many packages sitting by the door, man. It's hard to get in the house.
Yeah, I know. We were kind of late this year. We just got our Christmas tree up today. So, yeah, we're busy, right? And my wife's taking my daughter to Cirque du Soleil tomorrow as one of her Christmas gifts.
Nice.
So, yeah, I'm going to send the invite there for Lulu. There it is, Lulu. It's okay to be late. It's okay. Everybody's late sometimes.
They said, "Oh, you and Gerald need to work on your beards to get to mine."
Yeah, well, I have to keep mine kind of short because, like, I work in a really dirty environment. Like, you can see my hands. I have, they're all taped up. My hands got really chapped badly because of the water, because I work on a water jet, right?
Yeah.
It's really dry, and I'm constantly getting my hands wet. And yeah, it's just brutal. My hands are all beat up. I got an eczema. So I've been using hand cream. Oh, it's just a disaster. Unbelievable. So this morning I had to get up early at I had to be on the road by like 7 o'clock. I had to go pick up my snow tires from the locker.
Mm-hmm.
It's minus 15 degrees Celsius.
Oh, no, thank you.
It was so cold. Let me tell you. Oh my God, it was so bad. And I'm trying to pick up the tires because I got my winter tires on separate rims. So I'm picking these things up, trying to lug them into the back of the car. Oh, it was horrible. So that was my morning, and then I had to get all the stuff for the Christmas tree, put that up, and it was just one thing after another. So I finished my afternoon shifts. So the next 2 weeks I'm on days, but the week after is Christmas. So my last day of work's like the 23rd. So
Hallelujah.
Hi guys.
Hey.
I'm glad to see you, Mike.
Yeah, I'm back. I'm always around.
No, like last week you did a Saturday and I missed it, and I'm like, how did I miss it? I didn't even get a notification or anything. You know, it was like, Well, I'm glad to have you on your channel.
Yeah. Great. So you all ready for Christmas?
And you were talking about boxes. I'm trying to get rid of boxes. I've got so many boxes, like stuff that the kids, they've outgrown. I need to, kind of empty boxes. Like trying to make room for the Christmas tree. So that's what I've been working on today.
Yeah, we did a lot of cleanup around the house and got our tree up and got my snow tires on today. So I was a busy guy, and then I had to get groceries and no time to work on my projects. It's like, oh my God, I gotta catch up tomorrow. So, but yeah, before we went on air, Nathan and myself, we were talking about all the Don Smith stuff. So we're gonna start there tonight. So, Nathan, if you want to jump on that and kind of get everybody up to speed on what you've been doing.
So basically what we did was we did the conversion back from the cold energy to hot energy. And I noticed right away it was like Don Smith's invention where he took the coils and he's putting energy into the secondary coil and then he's pulling out the energy. So what my next step is to kind of produce something like he did, but I'm going to do it in a pretty unique way. I'm going to add some features from some other people in there. So I'm going to end up like Ian. I'm going to take a 4-inch Tesla coil, 4-inch in diameter. I'm going to put 6 rods down it, and I'm going to use the energy from one rod to see if I can't get enough energy to produce a loop back to the original circuit and then run a bypass on it. Now, if I can get this, I may need a capacitor in the middle just to cover the distance so that it doesn't shut off at any point. But I think I can be able to do that with the conversion. Now, that means that all the other 5 rods will be energy producing. So I'm going to be able to pull, maybe a motor out of one or whatever it is. I'll show a cap bank full, and then we'll have to see the depletion rate of that cap bank. So what kind of things I can run on it before it depletes. Once we accomplish that, we'll pull over unity on the device, obviously because of the loop and then all the extra energy. And I think it's going to be really cool to put this together. Mike was talking about a way for add volts and amps together, and I want to try that. That's going to be one of the next things I'm going to do on my show. And then we're going to go from there. That's really where I'm at in this next week. I'm going to be building a ton of different little coils in order to put them together. We're going to use resonance in this. So basically, if you don't know the times two method in resonance, it's basically you take a string and it'll make for lack of a better term, like a bubble type thing like this. If you divide it in two, you get two, but you get the same length and you got the resonance frequency. Now, in the way that works in radio frequency is there'll be a spot where there's resonance in each one of the areas where they come back together like this. And you can hit them on your oscilloscope and they'll produce energy. So we can get more windings out of the coil by doing this method, by multiplying it out by 2 each time. And then we can really get some power out of this thing. That's one of Don Smith's things. So when I say we're going to do that, that means that we're going to hit that over unity, and then we're going to go on from there and finish out the cold electricity side of it. But I'm just kind of excited to get that part done. I can't hear you, Mike. Maybe it's mine. Hold on.
Sorry, my mic was on mute. What he said was you could also do quarter or full wavelength, which means, if people don't understand, say you got 50 windings and you want to double the amount of power, you go to 100, or you could go from 50 to 75 or add just 25 more windings. So it's always a quarter or a full wavelength. It's basically like two antennas talking to each other. Easiest way, to describe what's going on.
Well, because it's all RF, and then that's why the conversion back to regular energy matters so much. Once you get that, it's pretty much game over. You can do whatever you want.
Yeah, and the thing is, I like to stress too, when you're dealing with Don Smith stuff, it's lethal. Okay, we're not talking about, Don Smith is creating the cold energy and the RF frequency and all that at the beginning of the circuit, but at the end of the circuit, when he converts it back into real power that you would use for utilities, it's now lethal. So always take precaution. Don't mess around with it. If you're not an advanced builder, if you're not, electrical savvy like our panel here is, just stay away from this stuff. I learned a few times. I got a couple damn good lifters in my day, and I'll tell you, it doesn't feel good.
No,
it doesn't feel good at all.
No.
If you have a pacemaker, absolutely not. Do not attempt any of this stuff. Lan is saying, why is it lethal? Well, when you convert it back into real power at a low frequency and a higher amperage at a lower frequency, it becomes lethal.
Yeah, so basically we went around over 200 kilohertz down to about 50 hertz. Right. So, or 60 hertz, whichever. That's the problem there. So what does it do? It brings your amperage up and it brings your voltage down. So it may be, say, 20 volts, but you're going to get 5-6 amps out of it. So that may not be completely lethal yet, but as soon as you start multiplying things and putting more things into it, it's going to get that way because you're dealing with, voltage and amperage in that way. So if you're not careful and you put two hands on something when you shouldn't, that's when it gets you. That right there, that's when it gets you.
And even at that voltage that you were just referring to, 20 volts at 5 amps, that's enough to stop a pacemaker. Okay, so please do not attempt any of those experiments if you got a pacemaker. You're just asking for trouble.
Yeah, and guys, we're not on a breaker here, so it's not like your house. Your house may save you with that breaker, there's no breaker on this. This is it's going to keep going. So
most new houses now you have the CFL cutoff breaker, and
yeah,
thank God for that. Just too many people were getting killed when they were around the bathroom sink with a hair dryer. It falls into the water by accident, and you get zapped and get killed. So too many times that was happening. The electrical engineers at the time had to come up with a fail safes if something like that were to happen. That CFL would protect you from a lethal shock. So yeah.
Not only that, when you start putting this stuff into a cat bank, the cat banks are really, really good at zapping the living daylights out of you. So
oh yeah, it's instant death. Like I had, this going back years ago. I think it was a 64 volt. I think it was a 10 microfarad or something like that. It was very small, but it burnt my fingers when I shorted it out with my fingers. I got a burn. I actually had a welt on my fingertips. So even though it was a tiny little cap, it had a big punch, and it's instant heat.
Yeah.
Because when a capacitor discharges, it's full out. There's no control. It's coming out. There's no control on the current. It's full out. So please.
Yeah, that's why. So yeah, just as long as you're cautious with it and you understand what you're playing with and you understand what to do, you'll be all right. Never try to touch it with two hands. Turn on the experiment, keep your hands away from it, and then, just have your meters connected ahead of time. So, with that said, that's kind of where we're at, and we're looking into some of the other things Don Smith was doing and the connections with it, things like that.
I want to share my screen. I want to show the one Don Smith. Let's see, do full entire screen. Share the audio. Okay, can you guys see my screen here?
Yeah.
Can you? All right. Let's pull that up. Okay. And finally, I waited for a long time, but I finally got it in. I got my
There it is.
Tube or plasma tower, they call it. They're hard to get. Now, apparently Amazon managed to find a new supplier, and I was able to jump on it pretty fast and pick one up. So yeah, it came in today. So the reason for it is I want to work on the Don Smith stuff, but the best way for setups is to use the plasma column. So the power supply to run this is about 12 watts. Now, I've done some preliminary tests with it, and it works fantastic. I could probably get a lot more power out of it, but this is just, off the fly. I'll show you the experiment in a second here. If you haven't subscribed to the channel, bottom right-hand corner, also give me a thumbs up at the end of the video. And also in the description, I got my link for my PayPal, my Patreon, and all that stuff there. Just click on the links there, and you can be a part of my Patreon page, help support experiments like this so I can buy this stuff and show you guys how it's done. So I wanted to do something really quick so anybody could do it. You don't have to have a machine shop. You could just do it with household materials. So I was able to save one of these old towel rolls. This one here is probably about 2.5, 3 inches diameter, and it fits perfectly on top of the plasma ball or plasma column. So basically what we have here, I'll kind of describe the circuit. So it's an AC current. It's alternating at a high frequency. So what I did was I took the 3-inch diameter roll and I put regular household aluminum foil. Now I'm finding too that the thinner the aluminum foil you use works better. I'm finding a heavier gauge takes longer for it to charge and actually accumulate the static charge on the surface. So this is just something really quick that anybody can do at home if you have one of these plasma towers. So basically what we got to do is we're going to put this on top of the tower. And it worked out to be the perfect diameter because it doesn't touch the plasma ball at all.
Nice.
And if you look here, you can see that there's a gap. And that gap's very, very important. This is where a lot of people go wrong with the Don Smith system, is they put their wines directly on the tube or directly on the plasma ball. Even the support, like if you're doing like a coil setup and you got a support device, it cannot touch that bulb or the tube. If it touches it, you're losing power. It's shorting itself out. So it's very important to have that gap. I'll just try to tilt it over so you can see that there's about a 1-inch gap going all the way around it. This is extremely important. All right. So basically the one wire comes off. That's all you need is one wire. It's basically the Tesla one wire system. So basically it goes from the bottom of the tube attached it there and goes into the full wave bridge rectifier. Now I must add too, this has to be a high voltage full wave bridge rectifier. If you use a regular rectifier on it, you're going to blow it up. So you got to use something that can handle about, I would say 10,000 volts. All right. So 10 kVA. If it can handle that, then you're good to go. So it's your regular bridge setup. So the two wires here, positive, negative, that goes to the battery. All right. And then the other positive, negative go to the capacitor. That's a 200 volt, 140 microfarad capacitor. So you do need capacitance in this. But because I'm rectifying it right away, I can dump it into a DC capacitor. All right. So we got that. We got the bridge rectifier. Now we have the ground side. Now it's a Tesla one wire. So positive from the tube into the full wave bridge of the positive of the AC coming in. And then the AC negative coming out, you ground it to the stove or earth ground or whatever good ground you can find. This seems to work very good for me. So that's the one wire system right there. And now we're tapping off the two to run the light bulb. The other two, it goes to the capacitor to give it more capacitance. And the other two wires attached to the capacitor just tells me how much voltage is in that bulb. So it's, to say the least, very impressive how fast it charges up. Extremely fast. So what I'm going to do is I'm going to shut the light off here. All right, and I want to show you how fast the sucker. Can't really see. Right now it has 3.5 volts in. All right, so we're going to put this on. It is now started. Look how fast it's climbing. Okay, we're already at 100 volts. Look at the light. And that's decent. Look how bright that light is. We're at 129.8 volts. And it's staying there. And that is fully illuminated. It's equivalent to 9 watts. Now, I could probably get a lot more power out of it. There's the tube up there. So
nice.
Resonating. So the tube's acting like a bit of a dielectric. And then you got the thin. Actually, originally I tried the ground with my body. That was a mistake. It gave me a so I decided, okay, we're using the stove as the ground. So it's holding a steady 129.9 volts, 130. So that's it, man. There you go. There's instant power. Look how bright that sucker is. It's fully illuminated. So it takes 9 watts to fully run this because I tested it with the watt hour meter to the wall. So it's equivalent to a 60 watt bulb. That's what it says on the package for it. But yeah, here's your Don Smith system. Easy, easy, easy to do. One wire system. Plasma tube into the rectifier, ground coming out of the rectifier to ground. Then your two positive, negative that's been rectified to DC. Go to your light and then branch off that to your capacitor to give you capacitance. And there you go, guys. You got it.
How much do you think you could
Look
put
how
low?
bright it is. Like
you
I got
add
the light off, so But anyways, I'll turn the light back on here. But let me just come back here. That's it. That's about as easy as it gets.
Nice.
Super easy. So you can, what Lulu was saying, can you add more to it? Yes, you can. You add more of those. All you have to do is add more tubes with more tinfoil wrapped around it and just sit it right beside that tube.
What about adding a more load just to that one? You
could. I imagine it'll definitely have a certain limitation, but you just tap off more tubes that are completely isolated from the whole system. They're just feeding off that flux field.
Amazing.
That flux, I'm disturbing the magnetic flux, the energy that's in that space with that energy.
Like usually that energy would be lost.
Yeah, I'm catching it with the tube.
Yeah.
With the tinfoil. Yeah.
Very cool. Very cool. Like really.
So the tinfoil is pretty much picking up static volts.
Yeah. Yeah, it's a static. Yeah, heavy side component.
Very cool.
There you go. Heavy side.
That'll work great with my electrics that I'm putting together. I got 2 tubes set up to do static electricity, -1, positive in the other. And I'm just looking to put static into them and then fill the tubes with various different things. So first thing we're going to do is some sand. And then I wanted to use some dryer sheets to make sure that it's pulling the, pulling the static on each thing. And then I'll use a static meter in order to see how much static's on each side, if it pulled negative or positive. So yeah, it's one of the other experiments I got. So that's pretty cool.
Yep. Yeah, as easy as that. Like I just thought of the idea. I wanted to order. I have the ball, right? But it's very easy to make, hard to make something to, pick up that flux field, but use it around ball. So I searched around. It was really hard to find those tubes, but every now and then I actually got that one off of Amazon, believe it or not. And they're very hard to find. There's only a very small selected companies around the world that actually make it. So
I'm going to have to look for one of those now.
Yeah, I got mine on Amazon. They might actually still be there. Yeah. That one, I believe, was like $50 or something like that. 50 years. No, sorry, that was more. It was 120 Canadian, something like that. Yeah.
So someone asked why some people make a slit on the tube.
The slit on the tube.
I don't understand why you'd have a slit on the tube. Or is he talking about the outside one with the tinfoil? Your mic's off, Mike.
Sorry. All it is a paper tube, and I wrapped tinfoil around it. That's it.
He said yes, it was the outside one he was talking about.
Yeah, the outside tube, you could use glass. Glass is a great dielectric. You could use glass, anything to support that tinfoil. So even PLA plastic from 3D printers, they actually are excellent dielectric, actually excellent for that experiment. So you can 3D print a column and then wrap your tinfoil around it and just attach a connector to the tinfoil. And there you go. You're done.
Couldn't you make a high voltage capacitor out of that foil on the outside since it's getting charged from the inside?
Yes,
then you just put the clear sheets in between it, another roll of foil around it.
Yep, exactly. Yep, you got it. And that's picking up the heavy side component, the static field. Yep.
So, would it shock a person if they touch the oven while it's in ground?
Actually, no. I touched the oven while I was doing the experiment. It didn't affect me. It was weird. But if I just grabbed the ground wire on its own, ouch. Yeah, about 2.5 kV. Right. Wow. So, yeah. The static field has a really peculiar effects on how it reacts with the surface.
Oh yeah.
It's a weird phenomenon.
You got like I have melamine on the top of my table, and that plasticky substance right there, man, it's really hard on electronics when you have static electricity. It'll start burning them all out because it goes right through it.
Yeah, yeah. And I've touched the actual tinfoil while it was working, and you could see little arcs coming off. And if you're not careful, you could actually get RF burns. So
Mm-hmm.
yeah, you gotta be. Yep, you'd be surprised. Actually, I've seen people actually light up a cigarette by the arcs coming off that. Yeah. Oh yeah. Just with the tinfoil. Yeah.
Nice.
Yeah. So that's the heavy side component. But Don Smith understood this very, very well. And that was just one of many experiments that he built. So, and a lot of people try to replicate it, but where everybody goes wrong with it is their apparatus is touching the tube. You cannot. It has to be at least about ½ inch to 1 inch away. If you're touching the glass in any way, shape, or form, you're actually shorting it out. You're losing power.
So it's no different than a Tesla coil rule.
Mm-hmm.
Got to keep it at, you know, I mean, they're usually about ½ inch to 1 inch away, depending on which one you're using.
Yep. And it's for a reason, because when you're dealing with the heavy side or electrostatic field, the second it touches the surface, it's basically made that ground.
Yeah, absolutely.
So, yeah, it's cool. I like that plasma ball. It's a beautiful light. Beautiful light. You could do a lot with it. You could tap off as much as you want off it, provided that you don't touch the tube.
So have you ever split the tube, or split the foil and did two?
Yeah, you get double the power. That's the great part, because plasma ball is an open system. You're not directly tapping off it, because the plasma ball is creating that heavy side component around the space. It's now energized around that space. So if you have any conductor that's within the proximity of that space that's energized, you're going to get energy transfer.
You know what's funny about it is you hear stories about Tesla weighing the copper. Okay. It wasn't about the thickness or anything else. It was about weighing the copper. So if you look at this, it's like the tinfoil is so much aluminum right there, right? Mm-hmm. But then if you put wire around it, it's no different than a Tesla coil. If I took 32 gauge wire and wound it probably on the outside, I'd probably still get a field inside the coil. Mm-hmm. But you only make that conversion in your head if you understood that Tesla was weighing the amount of the copper that he was using. You know what I mean? Because then now you could just equalize it and you go, okay, well, now I understand that I don't necessarily need the wire. I just need the metal itself. So if I oscillate one field to the next, that's basically a Tesla coil. And it comes down to making it so much easier to convert your experiments because now you see it.
Mm-hmm. Yeah.
So.
Yeah, Tesla never counted windings. He went by mass.
Yeah.
And he actually said that in his literature. I don't count the windings.
Yeah. Well, he manipulated his coils too. He was putting things down the center in order to manipulate the coil. He liked putting Tesla coils on their side and running it as a bipolar coil, and then he'd stick things down the center of them, and he would change the frequency of the coil. And a lot of people didn't know that. I figured that one out when I started working with it. Mm-hmm. So it was something he originally already knew how to do.
Yep. And we're just relearning it.
Yeah, we're just relearning because it wasn't passed down.
So if he went by mass, it didn't necessarily have to, the gauge have to be uniform all the way. He could have at one point in the middle of the wire, like make it thicker in one area and then thinner, and that would wouldn't that push more energy through when there's a thicker part, right?
So check this out. You could take two different coils and solder them together, and it'll still function as a Tesla coil. So it could be 20 gauge on one side, it could be 28 gauge on the other side, As long as they're soldered together as one unit, it operates just like a Tesla coil.
Yeah, it all depends on the mass. So,
Yes.
and the way Nathan's doing it, it's by how many turns according actually length. Let's say length. So Don Smith always said your divisions have to be to get a full wavelength, you have to double it, right? And if you want, you can even do quarter wavelength. That works just as well as well. So, keeping. I wanted to talk about the wire.
Absolutely.
I was talking to Nathan before we started the show. So you take if you want to get
Mike, real quick, just like octaves. Just keep that in reference in your head when we go into the next level. Sorry, I had to interrupt you there for a second.
Yeah.
It's because it becomes very, very important in the next step when you start learning about frequency and which octave you're in and how to convert. That's going to become extremely important. Anyway, go ahead, Mike.
Yeah. So in one of his lectures, this was, I believe, the Tesla Tech conference they had. I believe it was 1994. Don Smith did a lecture. So he got a wire like this, just any wire. And if you want to get sheer amps out of it, so you're going to fold it in half like this, all right? And then you're going to start wrapping it at the connected end where it's looped, and you're going to want to wrap the wire around like this. So at the end, you got the two open ends. Now you can attach your center tap to a second coil. The other wire would be your ground. Your other coil would be the positive. So where would go positive and through the coil to the negative, connect to this wire, which be a center tap, goes through the coil, all right, and then comes out the other end as negative. So what this does, this wire configuration he showed, will give you all the amps you want, okay? So it'll be a lot of amps, low voltage. The other coil that you would make traditionally, it would be round clockwise. When you wrap this wire with the double-ended connected at the beginning, when you wrap it, it'd be counterclockwise. And a lot of people, when they went to his conferences, they didn't get it. But this is where you get your amps. Also, the wire thickness has to be a lot bigger.
So, Mike, just so everybody understands, when you build a Tesla coil and you build it with the winds backwards, what you produce is a ton of heat. And as you produce a ton of heat, you produce a ton of amps. So that's just like what you said. So I fried a bunch of circuit boards trying to figure that one out, and I had it backwards the whole time and didn't realize it was. Now I run it, the same way as the wire, and it works perfectly. But it's that little trick that you learn right there that's so awesome.
Yep. Very cool. But see, Don Smith, he was so cryptic. You had to watch his stuff. He left a lot of open ends. Mm-hmm. So it took me a long time to understand what he was getting at.
Yeah, a lot of the stuff is just start putting things together and see if they work and see if it matches what he's doing. Just go with everything that he says to do right out of the box, and then you'll be okay. It's when you try to convert stuff in your head and think it's the way he's doing it, and you're not doing it the way he's doing it, is when you have a problem.
But again, I have to stress, when you're doing the Don Smith stuff, especially the coil ones, creating the amps with the one loop wire, very dangerous. You're getting into lethal power at this point. So,
well, I'll tell you what, Mike, I'll do it, and I'll try to show it to see how many amps I can pull out of just one coil, because I have coils set up, and all I have to do is move over a winding to one and just run it backwards. That's it. I have some extra wire around here. I'll just use the copper tube that I have for my primary, but I'll put one on backwards, and then I'll start up the Tesla coil and see what it does.
Yeah, you might be pretty surprised on how much heat that secondary winding is going to create.
Oh, I won't be surprised at all. I've seen it up front. Yeah,
Yep.
they don't work too well like that.
Yeah, you could fry wires, like you could get hundreds of amps going through that wire, because you got to realize you're running the primary at such a high frequency. And when you're going really super fast and then you slam on the brakes,
Yeah.
basically, you're
Yeah,
slamming on the
basically.
brakes. Yeah.
You just went from 200 kilohertz down to 60 hertz, man, in like no time fast.
Yeah. And you went from like maybe a half an amp to like 300 in a matter of seconds.
Yeah.
Yeah, we're talking some major horsepower here.
Yeah, so if you're right, and then did you show them the way they can to add the voltages together? The voltage in the amps?
Yeah, well, you have the one coil that's in clockwise traditionally, right? So that stays the same. But the second coil that you add at the center tap, that must go counterclockwise. This is where the slowdown of that high frequency, now it's got to go from spinning clockwise down to counterclockwise. All right. So if you don't have a heavy gauge wire, you could actually probably fry the wire. So, yeah.
So you basically, are you saying just make a Y configuration out of the wire that you're using? One comes in as volts, one comes in as amps, and then they come back together as combined voltage.
Right. They connect at the center tap.
Yeah.
Right? So you're getting the far end of the amp side, that would be your negative, and the high voltage of the primary coil would be your positive. They join it in the middle, kind of like series, like hooking up a battery in series. Same format.
Well, a lot of people out there are probably putting this together in their head, and they go, okay, well, I could get a static machine to get the positive. I can then put a magnet and rotate it and pull the amps off of it. Now, if that Y configuration works in that way, all you simply do is put it through a little coil, or maybe not a coil, just hook it straight together. We'll find out which, but that'll convert your volts and amps together. Now you have a massive voltage and amperage, which is out of this world.
Yep. Yeah. Exactly.
That's a massive key to free energy.
Well, that's why they do it in the transformers hanging outside in the on the poles outside. It's in the Y configuration, right? Same format.
There you go, guys. Make sure you write that tip down, because we're gonna be testing that. That's for sure.
We're gonna be frying some wires.
Oh yeah, I'm gonna get me a battery cable. You know what I mean, for the amp one.
Yeah,
and then, well, it's gonna go back into the smaller one, so the voltage one. So do you diode that, or?
Yeah, you have to put a high voltage diode on it, so it could only go in the one direction. Very good point. Very good point. If you look at Don Smith, his schematics, that's exactly what he has. Or in one case, I believe, if I'm not mistaken, he put a spark gap there.
That's what I was going to ask you. Can I put the spark gap there and get it? Because that'd be a better break than a diode would.
Mm-hmm. Yeah, you could put a spark gap right there. It would jump the gap, no problem.
Yeah, let's try it that way, because I think that'd be better, because I think a diode would fry on me. I think a spark gap would be a perfect jump.
Oh, man. You're gonna be putting out some serious amps. I'm talking not tens of amps. I'm talking hundreds of amps.
Oh, there we go. Fry it and find out. That's what you're gonna find.
Ooh, I think I just created a monster.
Well, you'll get all the credit for it. That's for sure. We'll make sure that I just put it into an electrical box and make sure it's grounded, right? Yeah. And then try it with some fuses.
Yeah, exactly. Oh, we got Benny here. Mr. Benny.
What's up, Ben?
Hey, what's up, everybody? I didn't realize you guys were on tonight.
Yeah, I kind of thought about it yesterday at work, and it's like, yeah, maybe I should do a show, yeah. But glad you came.
Yeah.
Better late than never, right?
Yeah. Yeah, I might have to dip out to do a couple of things, but I'll be back.
Yeah, the next week's gonna be busy for everybody. Christmas around the corner, and people getting their last minute shopping done and stuff like that. I get it. So I'll try to. Well, I'm back on days next week, so I will do a show next Friday night at 9 o'clock Eastern, like normal. I had the edge to do a show tonight because, yeah, I just like coming on air and chatting it up with everybody and get some great ideas and hopefully help somebody out too in the process. So
Yeah, I'm gonna have to do all my lab work here in the next week and a half, and just get it pre-taped and done. You know what I mean? While I can, so that I can run everybody around for Christmas time and do. They can go shopping and all that stuff.
yeah, when you're doing the Don Smith stuff, make sure you have a good kill switch.
Oh,
You might,
big red button.
yeah. You might need it. I don't know, Ben. Were you hearing the conversation we had just earlier, or you just jumped on?
Oh, I don't know what he's doing.
But
yeah, that's gonna be awesome. Though we'll have to try it at low voltage and then see. You know what I mean? Well, as low as we can, and see what it is, and make sure our meters are hooked up ahead of time. Because I need to pull some analog meters, buy some, if you know what I mean, for this stuff, so that they're already done.
See, a lot of people don't know. Don Smith worked for the Department of Energy. He worked with a company. It was an oil company, and he was the guy in charge of finding the geological survey for oil tapping. So he had to find the areas where the oil was. So he started dabbling with the stuff, and basically, he mentioned a few things in his findings to his superiors at work. And to make a long story short, some of that stuff didn't go over too well. And eventually, he was making a lot of money at that time working for, the Department of Energy. And they kindly showed him the door one day just out of the blue. So at that point, he said, screw it. I'm going to start working on this stuff. I'm going to start making energy systems.
Nice.
So, yeah. So, yeah, he has an interesting background. Very, very knowledgeable guy, very intelligent, but also very cryptic. So, his videos, yeah, they'll give you a lot of great ideas, but a lot of questions that he didn't really answer. And I think he did that for proprietary reasons too, right? Intellectual knowledge. But people are catching on to it. There's been a lot of good replications out there. So, yeah, he did very well with it. Yeah. But unfortunately, when he got into I think it was in his mid to late 60s, he started getting a lot of strokes. He started getting mini strokes. If I'm not mistaken, it was about 2011 when he passed away. Yeah. So for like most of the 2000s, I think he had his first stroke around 2001. He's having all these little mini strokes. Now, playing with that amount of energy that he was playing with, I wonder if some of the stuff he was doing was giving him ill effects. So this is the other concern. When it's one thing to work with Tesla stuff at high voltage, high frequency, but when you start stepping it down to regular voltage, it's now parasitic power. There could be some health issues that might arise with the human body being around that amount of
there is with hot voltage and stuff like that. Absolutely. Now, I prefer the cold voltage, to be honest with you.
Yeah. I think that it's kind of hard to label it. That might have been a cause of his health issues down the road. I can't really say for sure. I'm not a doctor. So, but it wouldn't surprise me. He was dealing with some real funky power going on there. Like he was going way excessive power. Like we're talking megawatts of power.
Oh God.
Yeah.
No, thank you. I'll stay away from that.
Yeah, and that cannot be good for the body. It cannot. So yeah, always take your own discretion. Safety, definitely 100% concern. Make sure you're very, you know, advanced with your electrical knowledge before attempting that stuff. So, yeah, Don Smith is okay. I stepped away from it because I was seeing some stuff there that was kind of worrying me, especially with the voltage and current and the spark gap going on. I was worried about, possibly getting an X-ray. Uh, what kind of emissions that I was transmitting out. So I'll dabble with the stuff once in a while. The one we're just talking about, with the two coils going two different directions, that's the one you got to be careful with. If you're playing with the plasma ball stuff like I was, that's different because you're using a high voltage, high frequency, heavy side field. And that's safe. That's okay. You're not going to have any ill effects from that. But the other devices he was making, I would be very careful. I would be very careful.
Yeah, like I said, I just want to get over the Unity thing and get it done and show people, and then let them experiment on their own. Because I have other parts of this I really want to get to. Because I'm working with the cold side of it, and I want to push the rest of that out. It was one of those things that came up, but I want to show it and show it the right way. So when I go back to that Tasikiba machine, I'm going to be able to put that thing together pretty easy.
Yeah. Yeah, sounds good. I'll be.
I finally put water in this, but I put sparkling water. Okay.
Okay. Nice.
It feels like the whole energy field within, I'll say maybe 3-4 feet. All of a sudden, everything around this area, if you passed by it, you felt the energy. How do I know? The kids were cleaning up really specific around this area, so it was giving something because they were hanging out all day today, within the radius of like 4 feet. So I don't have anything to measure it with, but I could feel it with, our dogs, the kids, all of them. So it has some effect, just don't know exactly what, but it worked. I put sparkling water in it. I figured, the bubbles might, ignite it to work better. I don't know, but yeah. So
that's interesting.
Yeah,
I'll have to try that sparkling water, huh?
Yeah,
that's like Perrier or something like that.
This one, like St. Pellegrino.
Okay,
yeah.
Sorry, kind of bring me up to speed. What did you do with the water?
Okay, so Nathan had the show about crystals and how like the crystal energy if you wrap coils. I happened to have one while he was talking, I did like a while back. I used to have water in it, and that whole area would just it felt alive. And then I forgot to put water in it, and it just sat there. And then he was talking about it. I'm like, something like this, and he was like, yeah, something like that. I'm like, yeah, but I haven't put water in it. So yesterday he was like, did you put water in it? Like a week had passed. I said, I forgot. So today I put water in it. That's as soon as I woke up, I found one of the bottles the kids left, and I just poured the rest of it in there. So I use sparkling water, but all day this area has been really, energized. And I was telling him I don't have something to measure it with, but I could feel it from how the kids were, how like our pets, they were literally within the radius of, maybe 3.5 feet, 4, like just around. So, yeah, I mean,
that was cool. Yeah, I was working on structured water for a long time. Also, just spinning water will structure the water in a vortex. So I created a tube, and at the bottom a hole with a reservoir at the bottom, and I put a pump to circulate the water back at the top. So at the bottom, so like when you pull the drain out in the bathtub, it starts creating the vortex. Well, mine was a continuous one that never stopped. So just by spinning the water and having magnets all around the tank, I've now structured the water. Very cool device.
Very cool.
Right on.
Very interesting.
Yeah. And I went even a step further. I got my piezo transducers, put it on the canister. It was stainless steel. I put the transducers and I put it at was it 528 hertz, and yeah, and I did it pulsed, and it would make this frequency, and it would just bombard and echo inside where the water is. So not only the vortex spinning, I'm also hitting it with those frequencies, the healing frequencies, 428, and 528 hertz is one of the best ones I've used. Yeah.
What do they use 423? I thought that was like the base.
420, that's the base one you can start at.
Okay.
Some people have multiple signal generators, so they have one at one frequency and one at dual channel, right? So, yeah, there's a whole list. There's a company out there that makes signal generators for this. It's called Spooky 2. They have a website, and they make those signal generators, so you can make your own structured water or whatever projects. It's a little box signal generator, and yeah, I hooked that up to the ultrasonic transducer and put it right on the side of the container of the water. And I spin that for about 7 days and start drinking it. It's all completely structured.
You learn something every day.
Some people do it with mineral water. Some people do it with distilled water, deionized water, whatever. Those work well.
Just as long as you're not restructuring urine like the International Space Station.
Yeah. Yeah.
They got to drink something, Ben.
I'm joking around, I know.
Yeah, recycle everything inside of space. It must be gross inside there. Can you imagine this? No, seriously, when you think about it, having a space station up there for say 10 years, you would worry about like black mold and stuff like that forming in there. Because of the condensation issue and all
Probably
that.
have to have like UV lights on for sanitation and stuff.
Yeah,
I think so too.
Yeah, if your buddy's eating peanuts the day before, don't eat any Baby Ruths the next day. Is that what you're saying? It could be recycling.
I never thought about it. Like, I know they recycled a lot of things, but I didn't think about the.
They can't have that many candy bars in space.
Like, imagine the most luxurious, like black budget, black project, space program that you can think about, and then they just put these guys in like this little like tiny dinky craft.
Oh yeah, that's terrible.
Yeah, it's almost like insulting. Like, you have better technology than this. What are you doing?
Oh God! But even if they were to like eject the human waste outside of the spacecraft, now you're polluting outer space. Like
Right.
that, you're launching a rocket, and then you have somebody's feces hit your window.
Yeah, it's like a
a
space crew missile.
It freezes. It freezes. It becomes like a solid rock. It freezes in space.
We got to go through the feces layer to get out to the moon.
Oh man!
Yeah, people on Earth studying this like asteroid crashing. It's just a lunk of poo.
Like in Joe Dirt.
That's right. Yeah.
It's like, well, Tom, what solar system do you think this came from?
Oh,
there used to be this
Uranus.
There was this great show back in the late 90s. It was called Dead Like Me. At the beginning of the series, she dies and she becomes a Grim Reaper. So, know how she dies? She goes to Central Park where she is, and she's on the phone waiting to do something. I forget what it was. But from the International Space Station, a toilet seat got loose, got outside the craft, came through the Earth's atmosphere and hit her and killed her. That's how she died.
Wow.
That's insane.
Oh my God. It was the best show ever. It was, if you could find it, it was called Dead Like Me.
Dead Like Me.
Awesome. Oh, best series ever.
Probably the worst way to,
Yeah, I got killed by a toilet seat.
No, a space toilet seat.
Yeah, exactly.
Yeah, that's even worse. What are the odds of that?
Exactly. That's funny.
Oh man.
The little segue there. But that's the thing, like yeah, it's like, what do you do with the waste in outer space? Like, especially like if you're going on a long mission and you're up there for months, maybe years, like you have to do something with it, and you can't start polluting outer, like already around Earth's orbit there's so much garbage from old satellites, parts of spacecraft that are jettisoned. It's a space junk, right? We have a problem not only on our planet with junk, we have the problem in our orbit around the planet.
If you think
Well,
about it, if we put like a huge magnet on one of those shuttles and actually go in orbit and collecting all of the stuff while we're still in orbit, don't you think we could really like reprocess it and make it something like manufacture it up there? I mean, all it takes is a huge magnet that you strap it around one of those, things and just fly around, pick it all up to the point.
Yeah, but the magnet would have to be the size of the state of California to pick it up.
Yeah,
It's-
and also
Right.
there's a problem when the trash circulates for that long. It's going really fast, and it's
It
just going to
is.
shred through things.
Yeah, it's the stuff is, from what I understand, it's about 30,000 kilometers an hour. That's fast.
Well, I mean, if we're going
Yeah,
that
like Gravity.
fast,
If you see that movie.
but if you think if we're going the same speed, then it would be just as if
It's relative. Yeah, it becomes relative. So
Yeah.
Yeah,
right.
yeah, that's true.
Hmm.
It's dangerous though. You have a craft, you don't want it to get nicked by one of those fast moving particles.
Well, you got to think, the International Space Station's up there. If one tiny little rock about this big hits the space station and it's going faster than the space station,
With all the crap that we have up there, it makes you wonder why, we don't hear about more incidences. Maybe they already have
Probably-
something in place that they're not telling anybody about.
I would say there probably is stuff happening. They just don't report it. Like maybe parts of the solar panels get hit because they spread out very far.
And I know they have to track it too, right? They have to probably constantly track it.
Yeah.
A lot of the Starlink satellites like fell out of orbit, and they reported that, like a bunch of them that just couldn't hold up in orbit fell back to Earth. So a lot of stuff does happen, like this. And then you had the Russian satellite that the Russians destroyed their own, satellite, and it was in very close proximity to the International Space Station. They talked about it for a little bit, and then it just, nothing happened. It jeopardized, it put the space station in threat of it, like from the what do you call it, the stuff that broke from the Russian satellite could have hit the International Space Station, and nobody really cared about that. And I thought that was kind of significant, like two levels. One, why shoot down your own satellite? That's one. Two, it's like, was it that important to jeopardize the International Space Station that they're still partners in? You get it? Like, it's a double thing. It's like they're destroying their own thing for a reason, and then they're willing to put the International Space Station at risk. What was so important that it couldn't wait?
It's almost better off that they allow the space station. Eventually, the space station that's up there right now is going to be decommissioned, and they said all they do is just let it fall out of orbit and let it burn up in Earth's atmosphere. That's the best thing to do.
Oh God! Hopefully, we are not below it when that happens.
Well, they will time it so it's over the ocean when they do that. So that's
smart.
That's what I've heard. That's what the plan is.
Well, I looked it up. Okay, on Google it says that they poo in a bag, they use gloves. Okay, then they take the paper in there and they put all that in the bag and tie it off, and then they eject it out to get burned up in Earth's atmosphere.
What they don't tell you is there's actually a target. So, like, you can have like 5 points or 10 points or even 15 points.
So their poo burns up in the atmosphere. So we're breathing their poo.
Hey, it's like playing that game Plinko
Yeah.
in outer space.
Oh,
See what number it's going to land on. The Price is Right in outer space.
They could save it. They could save the International Space Station, and they don't have to decommission it if they put little.
yeah. I would like to see it in a museum or something. Let me go inside and explore it. As a civilian.
I was thinking more of actually keeping it up there. Like if they put little thrusters, they could push it from that.
Well, that's what they do right now. They use these thrusters to constantly keep it in its orbit.
Okay,
But it will get to the. But I think it's also the safety issue too of the space station. It gets leaks, right? So when a leak happens, they have to block it off. They've got to figure out where that leak is coming from. Actually, I believe it was one of the Russian components that they had on the space station. I think it was over a year ago that they were losing pressure. And they had to go in there and they had to find out where this pressure leak was happening.
But they could still use it as a platform, even if it's unmanned platform. You could use the surface of it as a landing station for something that's robotic that really doesn't require human life, on it.
Yeah.
It could still be. I mean, we've paid billions of dollars in human money to get that thing up there. They're really going to just let it, when it could be used for future projects, if left, even if it didn't have humans on it. But the surface of it, you could build on it.
It'd be like an old redneck thing. We'll just hook a rope to it and bring it to the moon, and then we'll use it as the base station on the moon, and we'll drive our little moon cars around it.
Yeah,
we'll make it. We'll turn it into a rave. The International Space Station, a rave in space.
Rave in space.
We'll charge rich people a lot of money to spend the night on the moon.
Or recycling.
No. What you do with it? Here's a good idea: store fuel.
Okay.
Oh yeah,
there you go.
You can do that.
So
that's a good idea.
You get a rocket up there. You need more fuel. You stop at the space station, refuel.
Yeah.
Or have a rocket that's basically just a tanker to bring up fuel to that loading dock. So if you got a loading dock in space now, you could take one of Elon Musk's ships, go up there, refuel at that dock, and now make your trip to Mars.
And you could have that refueling station be manned by his robots, just as long as they don't rise up and revolt and refuse to work and whatnot. Demand fair pay or whatever.
Yeah, go on strike.
But there's a lot more intelligent things we could use it for other than just bringing it back.
Gas station.
Yeah, jet fuel,
that'd be the most
hydrogen.
Hydrogen, oxygen, whatever you need.
It would be like an outhouse on the way to Mars. You just stop in, drop the deuce and leave. Leave the seat up for the next guy and mess with him.
Or it could be used as the anchor point for a space elevator. You need something up there as an anchor point. And they've been talking about the space elevator. You need something that is, orbitally locked that you could dangle the space elevator, there's so many uses for it. They'll be if they don't use it for something after, it's no longer humanly usable, but just leveraging that, its orbit, it already is locked into an orbit. They seriously are probably the dumbest things that we've ever put in charge of that kind of science. Seriously. It's already paid for. Why wouldn't you use something that's already all the expenses, been taken care of, right? It doesn't make sense. If they don't reuse it for something, I don't know. Maybe this should be our project to NASA and say, hey, you know what? After you don't want it anymore, we have ideas for it.
Yeah. International outhouse.
Go fill up on your gas and let out your poo. There you go.
Yeah.
Leave a little gas behind for them.
Make it into a 7-Eleven or something.
Invented new forms of propulsion.
7-Eleven in outer space.
You get a Slurpee when you stop by.
Slurpee. There
You
you
better check the ingredients of that Slurpee.
Yeah, exactly.
Hey, I just got some of that freeze-dried astronaut ice cream from Cracker Barrel a few weeks ago. That was good stuff. I love that astronaut ice cream.
It's very good.
Oh yeah, it's like yellow snow. You better look around first because there ain't no lemons up here.
Yellow snow. Yeah, that's hilarious. I'm surprised. I'm surprised Joel hasn't joined us. He would definitely go off the wagon on this one, right?
You watch aliens are using the toilet as they come by. They're filling up, using the toilets on there. We just put a camera up there and charge people.
It's awesome. Yeah. Yeah, but yeah, that's a good question. It could be used for something. I think most practical, I think it'd be a gas station. Yeah. Gas and air.
Mhm.
Or,
Like a literal 7-Eleven.
yeah.
Yeah.
Yeah, put the 7-Eleven logo
That's
on it.
hilarious.
Well, yeah. If we're gonna do this, man, you got to have something out there that you can, go out mining some asteroids or something and come back and hang out in it. You know what I mean?
If you want to use the bathroom, you have to purchase something.
Yeah, that's right.
What a rule.
Unfortunately, there's not many other options out there.
Yeah,
You get
exactly.
the space hot dogs.
He's like, that's how
Space
they get
dogs.
you, man.
It's space dogs.
Oh, it'd be
We
great.
We only take credit.
Yeah. Make it into like a 50 diner up there.
Oh yeah, we still have it. It's not too far from where I live. The old 50s style. It was called the satellite. It looks like a UFO. And
Nice.
The girls would come out on the roller skates and serve you right at your car window. Yeah, it's famous. It's really well known here, and it's still around. It's been there since probably the mid 50s. Yeah.
Oh man.
Sounds fun. I like those old 50s style diners.
Oh, you'll have to go in there and make sure the light comes out dim in the bathroom, and then we'll go in there with some cellophane wrap or something and put it around the toilet so
Yeah.
so they can't see it.
Yeah.
But just like you do to your buddies when they're partying at your house, and they're staying over. You can't resist, man. You got to make sure the light's kind of dim, kind of turn that bulb a little bit so it barely turns on, so they can't tell. Put the saran wrap over the pooper.
That's hilarious.
And you leave all the cleaning products too, so they're easily accessible. So like he walks in, he's like, "Why is all the cleaning products here?" And then after it happens, he's like, "Oh, that's why. That's very convenient. I got to clean it up."
So great.
But in outer space, it'll be floating around, so it'll be getting in your face.
Oh yeah! Oh
It'll
my
be getting
god!
it'll be all in your hair and everything. Oh my god!
Oh wow!
Oh, it'll look like a trucker's restroom, man, where all the poo and pee's on the wall, and you don't know how it got there.
Oh wow! Maybe you don't want a blacklight in that place. You might not want a blacklight, guys.
Oh man, that's so bad.
Yeah,
Like some
there's
things you
no
can't
gravity,
unsee.
right?
Can you imagine that? You turn on a black light in your garage because you're doing like Tesla coil experiments with black lights, and all of a sudden it lights up everything in there.
Yeah.
I mean, how are you going to explain that?
Oh man, I'm freaking dying here. I'm laughing so hard. Yeah, it's like now you know why the toilet on the International Space Station costs something like $4 million.
Oh yeah.
It's a vacuum system. That's what it is. They stick a vacuum to your ass.
Oh, they're pulling it out, huh? They're sucking it out of your butt.
Yeah,
Yeah.
they have to. It's the only way. Because it's no gravity. There's 0 G, right?
Oh, no constipation for you then. They just
Oh wow.
put the hose up and you're done.
Yeah,
Are
you
you
don't
for
need
real?
laxatives.
That's what it is. They really use a vacuum.
It's a vacuum. It's a vacuum.
My
Yeah.
God.
Oh
Yeah.
my god.
You must be like, oh.
Oh my sweet cheeks.
I didn't think of there's no negative pressure. There's no negative pressure. You have to create it. Oh my.
I always wondered that on Star Trek. I never see the bathroom. Do they just beam it out?
Yeah.
Hey, it's 2 shells.
So,
Oh God.
oh man.
Yeah, it's
You don't know how the 3 seashells work?
Is it the 3? Yeah, is it 3 shells? I'm sorry.
Yeah.
Must be misremembering.
oh
They probably
about-
break it down to its organic materials and reuse that stuff. You know, like 3D print stuff with the organic materials, what they need up there. Like,
Oh, like the Martian guy?
well, I don't know what the Martian would.
Hey,
No,
if we can
the
3D
movie where the guy was on Mars and had to use the poo as fertilizer.
Yeah,
Oh boy.
I know now what you're talking about. Yes,
Growing poo potatoes.
yeah.
I was gonna say print a State Puff Marshmallow Man, like a giant marshmallow man.
he'd probably be as big as the ship because there's no gravity, so he's just gonna keep expanding and expanding.
Oh my god, can you imagine if they put us all on Mars together, man, in one of those little areas, and they just put a recording camera? It'd be like the Truman Show all over again. But us at the space station.
Hey, there's your next
What are you
video.
guys doing over here?
What we're talking about right now. There's your next video, Nathan.
Yeah.
We'll
Even out the
Ben
poo.
we'll have Ben the operator of the toilet, and then he'll make him.
Yeah, the thunderstorm toilet.
Ben's in charge of sucking the poo out of your butt.
No, we have to construct the thunderstorm toilet so it not only takes care of the waste, but it transmutates it into something useful.
It's the fresh air. It's like its own air freshener for the whole area.
Oh
Well,
my god!
if you watched the recent attempts at the thunderstorm toilet, it was only successful at turning the waste into petroleum jelly.
Oh man!
Oh,
Now we gotta get Gerald's job. What's Gerald gonna? He's gonna control.
oh man.
He's gonna fly the ship. He's the pilot.
He's watching it all fly by him.
Yeah. Oh god.
Oh, it's so bad.
There's so much material you could work with.
Oh yeah. That's so great.
We call it Spaceballs. That's already been taken.
Yeah. Like that lady on Spaceball, the maid. We turned from suck to blow. That's terrible.
Oh my god, so much material. Nathan, Pirates of the Caribbean.
Oh my god. Yeah. That'd be an adventure, man. Just get us all in a room. Yeah.
Oh jeez. That put us all on the space station. Could you imagine?
Dude,
Hey,
there'd be so many jokes out there, man. So many raunchy things going on. NASA wouldn't know what to do anymore.
oh my god, they'd be like, what the hell have we done?
Yeah.
They're probably like, you know what? We just don't want you to just stay up there. It's better.
Oh, so bad.
That's hilarious. Well, our live chat's really on fire tonight. Ben just went for a break.
Oh.
It's excited, like all the new generation, all their like songs about the skibbity and like I don't get it, but yeah, whatever. You know.
Yeah, the adventures we would have in that space station. Oh my God.
Can you imagine the experiments? Because we're going to end up over there, creating sparks or something in there. And
Oh man, we would depressurize that sucker so fast. Oh my God. Oh man, we'd be a freaking disaster. Why? They'll say, why is the space station like contracting and expanding, contracting and expanding?
exactly.
Why is the interior now glowing green?
Yeah. Oh man, that'd be bad. Have some green dye up there. We all look like green aliens by the time they put on the camera.
Yeah.
It was an accident.
We transition from the human state to the alien.
Yeah. We are no longer part of the human race. We're the castaways.
We'll blame it on a UFO came by and just transformed us.
Yeah, we got transmutated.
Oh,
Would be younger.
Take me to your leader.
yeah. Oh man. Oh,
That's a very high oxygen rich environment in there. So any ignition, oh God, we might have a problem. We have a problem, Houston.
yeah. We'd become a playable game or something, man. You know what I mean? Where they say how many lives do you have and how many experiments they do to blow it up. That'd be like the next video game craze. You're like, I want to play the old man. He always blows everything up. That'd be awesome.
See, if we go up there and we're all on the space station together, we now all of us take the names of the Star Trek Enterprise crew. So we have to have a Captain Kirk. We'll have a Scotty. What was the girl's name? I keep forgetting her name.
Ahura?
Ahura? Is it?
Yeah, communications.
Yeah. So all of us would have to have Star Trek names. That would really freak out NASA if we did that. There we go.
We got to find us a Sulu.
Sulu. We'll get somebody to be Spock.
Our own.
Oh.
Yeah.
What's that?
Create our own language, our own code.
Yeah. Yes. Oh man.
They'll grow special mushrooms. That's what they give us in our little kit to grow things up there in the space station.
Mushrooms. All right, mushrooms.
It's Mushroom Week.
Yeah, Mushroom Week. Yeah.
The ratings went up that week. Oh, that'd be hilarious.
Oh, we're up there. We're all smoking weed. Hot box the space station.
Oh, that'd be so bad. You know how many redneck inventions we can make with the extra stuff they had in that craft? Oh, yeah, that'd be great. Oh, man.
Like for a whole, not a long time. You need to like vacate it and give it to us for like a month. We will like turn it around. I promise you. Also, a month. We don't need years and years. Yeah.
We'll probably get a lot of good ratings on the NASA.gov website.
Yeah, that's what I mean. It'd be like the Truman Show. Real life people up there. We'd be selling products and stuff like that.
Do Free Energy Fridays live from outer space.
Yeah.
That would be that would be awesome. Like imagine like the whole planet like tuning in. That would be awesome.
We're all making rice-a-roni up there and showing the package.
Rice-a-roni. I haven't had that stuff in years.
Oh man, I have it all the time. That stuff's great.
Yeah, I haven't had that in years. Holy cow.
Huh.
Doing shrooms in outer space. That'd be hilarious. Be all hallucinating up there.
We'll probably attract them for real, the aliens. Like, there's no doubt in my mind they'll probably gravitate because now we'd be on the same wavelength as they are.
Oh yeah, mac and cheese up there. We'll have to have our own little rubber room in case somebody loses it. You just stick them in there.
Gerald will be in there all the time.
Oh, that'd be great. There'll have to be handlers that didn't partake, so that they can guide the rest of us.
Oh man, that's funny. Yeah, do a wormhole. A wormhole inside the space station. Oh God.
Oh man, that'd be so great. Yeah, I'd be like, what movie was that? It wasn't Independence Day. What was it? Where they sent the people up to mine the rock, and then they went to the space station, and the Russian guy was there, and they used it for a gas station. What was that? It was with Bruce Willis.
Oh, I think that rings a bell.
Armageddon? Was that the one?
It could have been, yeah.
Armageddon.
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 Yeah.
It's realistic. I saw it, Armageddon.
Yeah.
Yeah, that'd be cool.
Yeah, that'd be an adventure.
Yeah, you got to meet us before you get to the moon.
Yeah,
or to Mars, or
we're the gatekeepers.
Yeah. Check your credentials.
If anybody to check our credentials, yeah, it's us.
You got to take the shrooms and sit in the rubber room for an hour, and if you live, you can go on to the moon.
That's right. That's the test. Yeah.
Oh,
that's your sobriety test.
Yeah. Oh, that'd be great. Oh man, Alien would be stopping by just for a package of those, huh?
Yeah. They'd be just tuning in just to watch us. Entertainment value.
They show the camera pan into the hollow moon where the aliens are hanging out, watching our show.
Do you guys really think the drones are alien or human made?
What, the drones? Oh, they're our made.
Yeah.
The aerospace company I used to work for, we were making stuff for that. And that was about 5 years ago.
Desperately want to believe it's aliens that's not human made. Like
no, it's human made.
I so want to believe. Like, please be alien, not human.
It's yours. It's man made. It's man made stuff. They have stuff so advanced now. It's just they want the stuff to start coming out slowly. Because if they bring it out all in one shot, they're going to say, hey, wait a minute. You guys been lying to us for 50 years. We want some explanations here. So they're trying to roll it out slowly, the technology.
Well, it's more than that. If our enemies or anything find out that we have that great of a leap in all of this stuff, that's when we start to have alarm bells go off everywhere. It's not so much our citizens. They, oh, we got this, or we got that. Well, we knew they had it, but you get some adversarial nation, and then they'll be, oh, they have that. Okay, well, we better take them out before they get the next thing, and then next week you keep bringing out more stuff.
Yeah,
they won't know what to do.
Yeah, exactly.
They didn't realize how bad it was in their situation versus us, and it's like now you're going to find out.
Yeah.
It's
hopefully it isn't the hard way.
Show us your toys. Your toys are better than your toys.
Well, that's exactly what it is, and that was what Putin did, bringing out the Oreshnik hypersonic missile.
Yeah.
You mean to tell me the U.S. don't have hypersonic missiles hidden somewhere that they haven't shown? Of course they do. They probably have had the technology for a long, long time. They have to always have an ace in the back of their pocket. So when shit hits the fan, they can pull that ace out and play the card.
Yeah.
Right? we have technology, but we don't use it like, like 50, 100 years in advance that we have this is dormant. It only comes out for when the
From
generation is capable of actually navigating this stuff. Because, like for let's say our generation, how many transitions did we have in technology?
okay.
You
See, Kelly Johnson, the guy who was the head of Skunk Works, before he died, he says, whatever you see in the air right now, we have stuff buried in our complexes that are 50 years ahead of everything that's in the air right now. We're 50 years ahead of that right
Hmm.
now.
Yeah, I
So,
think.
the stuff that we have right now is pretty radical. Some, the F-22 and all the Reaper drones and all that stuff.
Oh yeah.
They're already 50 years ahead. It hasn't been shown yet. Like I said, they're going to keep that ace card in the back pocket. When things get really bad, they'll play that card. You know, the,
I
they're not stupid. They're
for
they
playing
know it's
like generational, generations and economy too. You have the economy. Like the population of planet Earth is growing bigger than, it's not a steady rate. It keeps on multiplying much, it's not like a
right.
double. So you have to, accommodate technology for a workforce. You have to be able to plan out that kind of level.
Hmm.
You have to keep people busy. You have to give them something. Yeah, like how Tesla invented his stuff. Then, so I don't know how many years later we started using it. So a lot of inventions happen, but we're not allowed to use it. Until a
Yeah,
certain time, and it all has to
exactly.
the population and the economy at the same time.
See, right now, you notice, we're getting very close to a nuclear war with Russia right now. We're basically in a Cuban Missile Crisis. With actually, it's worse than the Cuban Missile Crisis right now. And I found it kind of interesting that these drones are now popping up. This stuff going on with this UFO drones.
Hmm.
That's technology is coming out for a reason to kind of show Russia that you got some funky equipment. Well, so do we.
Yeah.
But they decide to do the drones.
Hey,
Not such a
what did you think about Trump saying to Trudeau that Canada should be part of the
yeah,
U.S.? He should be the
yeah.
governor.
He was serious when he said that too.
Yeah.
He was dead
They,
serious.
he went into women's rights and he should be wearing a dress. He wears every other outfit and paints his face. He might as well put on the dress for women's rights.
Yep, exactly. And he probably would do it too. Sad. I'm gonna just scoot out for a quick smoke. I'll be right back.
Okay.
All right.
Oh, I love it when they troll people like that. People would think they're not going to be trolled, and they always get trolled by Trump. I think that's hilarious.
I think
Um,
the best thing ever that happened to the United States, honestly. That's what I think. I think he broke that, like that, whatever they have there as the code, and they're all tied somehow. He's like the outsider that kind of illuminated things, like people, hey, wake up. There's something, it's not, you have rights. You have options. You don't have to stay in that same, methodology for politics.
well,
I like Trump.
yeah, what? I mean, they treated him so bad once he got out of office, and then now they try to be nice to him. It's only right that he trolls them a little bit. I mean, after all the stuff they said.
Absolutely. Absolutely. He's got the right. And I think he should actually, all these people that, did all these allegations against him and all this stuff, he should go, and, once he's president, and investigate every single one of them. Like, like what hand did they have in it and why, and restore rights, restore, the people's money, restore, rather than just, things disappearing. If anybody's going to ask these questions, it's going to be him. He's not scared anymore. He's the president. So
Yeah.
yeah.
Well, I'll be honest with you. I don't know that he's going to conduct them, but I think the people he hired will.
I hope so. I hope so.
Yeah, well, you know what? I'll be honest with you. Some of the stuff that they pulled off was just unfair. And it's not that I care Republican, Democrat. It really doesn't matter to me. I do care about fairness. So if they did it to him, he has every right to do it back.
Yeah. This is how I see it. He's not hungry. He already made his money. He's not out to create bullshit, non-for-profit organizations to steal money. You get it? But they are. The other side doesn't know what wealth is, doesn't know what foreign policy is, doesn't know any of that, the stuff. They're just, they work the little ladder up, and once they think they've reached that, like, oh, now it's the time for us to like steal the country, and that's what they do every election. But with his case, he's already, full. So for him, he's going to have an ideology of, well, let's fix things. I don't need the money, but I want to
Yeah.
fix things,
Well, if I was Iran right now, I'd be really pooing my pants because they're not going to get away with what they did lately, especially to Israel. And he doesn't like that at all.
I don't like, listen, that area is damned, whether it's from the Muslim side or the Jewish side. That area, we've been suffering with that issue for maybe over a century, and it's been sucking people's attention, energy, this, that, and at the end of the day, we care about the history and that, but not that much, you know. We like the fun things. Yeah, we'll put a Christmas tree or we'll enjoy this. But at the end of the day, it's one religion is what, 15, 1600 years old. Another one is, I don't know, maybe 3,500 years old. Another one is about like 2,000 something years old. We respect all of them, but it cannot dictate our lives in our modern day anymore.
Yeah. Well, Israel has a one-state solution, and they're about to fix their problem by doing it. You know what I mean? No more will they have that two-state stuff in their head, and they don't care what America says. They go on one-state solution, and that's it. Why would you have somebody adversarial to you in the middle of your country? That doesn't make any sense at all. We wouldn't put up with that? It's like saying, hey, why don't you go park in Kentucky and we'll just deal with it? We wouldn't do that. Why should we ever ask anybody else to?
Nathan, it depends on how you see it. It depends on how you see how history got unfolded. So you've got people on that side that believe that they were the origin, and they had people that occupy them. The other side says, well, before you even were there, we have ancestral roots of rights to this area. So it's a never-ending battle between who has the rights. One claims one thing, one claims another thing, and at the heart of it, really, they both of these civilizations did exist, but under different titles. There wasn't anything that was called Judaism, nor Christianity, nor Islam. It was a nomad land. It was pagans. It was, and then you had each group decided to come into like a little clusters, and then each one of them at one point said, oh, we have a messiah, oh, we have a prophet, oh, we have a messenger. It just, at the end of the day, each has a claim, but they all link to the one origin. That's what they want to fight about the differences, but they don't want to unify on the similarities. And that's what, in my opinion, I think they don't see what it is being human. They're missing it. They're missing it completely. And
Of course they are.
at the end of the day, we live here. Why should we continue to support any side on a fight? It's like,
Yeah.
we have veterans here that came back from protecting our country, that are living in homeless shelters. That's not fair. Why are we sending people to to pay for their war, and when we're not getting anything from it, and then where we just have our soldiers suffering, like let's spend that money on improving those people's lives than rather supporting a war that it's a pit hole. Like no matter how much money and weaponry you pour into it, it'll never end. You know?
Oh yeah, well, I agree with you there. I'd say just let them take care of their business and be done with it, because I'm frankly tired of hearing about it.
Yeah, I'm tired of money disappearing for it when we do really need it here.
Yeah. Like, oh,
Yeah.
that photo you had behind you made you look like you had one of those little visors on and your hair was coming out everywhere. Like, there you go. like one of those coaches or something.
Toupee. It's like a toupee. No, I'm just
That's
wondering
so
why
great.
my background is backwards. What's going on here? What the heck is going on here?
I don't know, man. That was too good.
Yeah, my background's. Why is my background's backwards?
Oh,
That is just weird. All right, we'll get rid of that. I just realized, yeah, my background was backwards. But it's showing me in the screen to choose my background that it's the right way. And then when it goes on, that's crazy.
no, I don't know.
I don't know. That's the first time I've seen that happen. Weird. So, is there any other topic we want to touch on? We got about another 20 minutes.
Oh, sorry. It's been a long day, man. I started like at 1 a.m.
Oh, did you?
Yeah, well, I've tried to get some stuff done, and then I have been having to bring my son-in-law to work and pick him up. So it's like, I don't know about you, but when I'm in the middle of doing something, it's really frustrating to get up and walk away. You know what I mean? Because I like it to flow and keep working. And then that way hours pass by and I don't really realize it. But
Right.
when it breaks up like that, man, it drives me absolutely insane. So, yeah, it's been an early one. So I wake up a little earlier than I normally do. So, what do you think about that? Oh man, the guy that tried to replicate Hutchinson. Like, did you see that?
Oh, yeah. I've seen that. Yeah.
So, what did you think about it?
I don't know. It's yet to be seen. I know that Hutchison, he was using electrostatics, he was using frequency, he was using about 3 different types of medians all at the same point. And he was probably doing some kind of distortion of space time. Like even Hutchison said, it didn't always work. He had to tune it, he had to play with it. And sometimes it would take a couple hours to get the effect. So
More than that, sometimes you said it would take a day or so to get the effect.
yeah, exactly. So yeah, John Smith died in 2011. Yeah, somebody was asking about that. Yeah.
Oh, yeah, I was pretty interested to see it. I went on there to see it, and it was very short. It's like they give you a few minutes, and they don't even really pull off the whole thing. Like I'd like to see it.
Yeah.
It's not that they don't have all the parts. It's just, you know what I mean? Kind of run it for a while. Let's see what happens.
Mm.
Yeah, he just said I need to get another camera, and it's like, what? Seriously? You didn't think of this stuff before you started?
Well, and you have all that electrical energy that is not good for a camera. That could damage or destroy a camera.
No, you got to have a camera at a distance with a good zoom.
Yeah, exactly.
Yeah, you don't want anybody anywhere near it, but they should have known that when they started it. As soon as you bring static electricity in it, you have to be at least 20 to 30 feet away.
Yeah, it's like, duh.
Like, have you never run this machine before or something? You know? And they show this thing, it's, big old, electrostatic generator over there. And it's like, okay, yeah, well, I knew as soon as you turned it on, 15 feet minimum. You know what I mean? You have to be away.
Right.
So, Yeah, man, I would have loved to see them get a little further with it. I don't even know. I know they probably did turn on the Tesla coils, but it didn't feel like it.
Yeah.
So
There, I fixed my issue. I had it on mirror.
yeah, I don't think people understand how important that Tesla coil is to making that experiment work, and then the point of saturation that they have to get to with the plate that they're using. In this case, they were using wood, so it was a different experiment. I didn't see the piezoelectric. They had a Tesla coil underneath instead of a piezoelectric buzzer. And when they put the material up, there was just a rock with piezo in it, but that's not going to cut it. So you got to remember what he was playing with, and he was playing with those crystal cells.
Right. He also had. He also said in his setup he had very large spark gaps going. So you're creating electromagnetic pulses.
Yes.
Right, at a very, very extremely high voltage. Like we're talking, 100,000, 200,000 volt spark gaps, what is extremely loud, right? Extremely loud.
Yeah.
Yeah, like you got to be behind a shielded, Faraday cage outside the experiment. It's not good to be anywhere near that while it's going on.
Not only that, they had all of the, all the plasma in a glass tube, which, don't get me wrong, it's a beautiful light. Yeah. I thought that was amazing looking, but it did absolutely nothing for the experiment.
Yeah.
It was just a waste of power. I mean, as soon as you create plasma in an experiment like that, you've just used it. And as a matter of fact, that's probably the reason they put it in the tube, so it didn't take in more energy from other things in order to run it. So yeah, that was kind of a waste. I didn't understand that, and they did not explain it. It was like me going in my garage and lighting up some plasma and showing you a couple of coils and telling you I'm going to watch this plate with my milk carton on it with my face on it, and then we're going to see if it flies up in the air.
See, the other thing too, a lot of people don't realize, you're creating a hell of a lot of ozone. So you can't be in that same space. It's not good for your lungs, right? Too much ozone.
Make you sick.
Yeah. No doubt.
Yeah. So I don't know, man. I'll watch it again. Don't get me wrong. I'd like to see somebody succeed at something and show it to me and prove it to me. But I'm not putting it out there as it's going to be the best. I don't think they fundamentally followed the rules to get some of this stuff working.
Yeah, and the other thing too is Hutchison had a lot of funding back then. He had Lockheed Martin, he had Boeing, he had some big backers, so he had the money to get that big machinery. He said at one point he had something like 50 tons of apparatus.
Yeah. Well, you wonder if Skunk Works involved. Well, that's probably where they got their tech for their next generations of stuff. Once they learned what he was doing, they probably recreated it in the lab and did it better.
Well, I think what they implemented some of the Hutchison stuff on the B-2 bomber, the stealth bomber. Yeah, the electrogravitic part. I think they had the leading edges charged. Yeah.
Yeah. Well, of course, Hutchison himself had to wait until the plate got saturated when he used the aluminum plate.
Mm-hmm.
And that's kind of one of those things going to take a while. If it's a 1/4 inch thick, you're a couple hours at least to run that stuff in order to get any type of saturation.
Yep.
And that's why Alexi uses, real thin 1/8 inch gauge, nothing thing. So it didn't take very long. But I don't think people took that into account, the rate of saturation of that thing. And then the voltage you have to do. So the Tesla coils would be like 2 power lines. And you're basically making a field of dielectric between the top and bottom. And then the point of saturation would be the aluminum in the center. So I don't even think they took into account the distance that it would take.
Yeah.
So it's like it's like a capacitor that the 2 plates are away from the center too far. So it's like a 3-pin capacitor. One side, and 1 plate in the middle.
Right.
That's what it's like. So if they're too far apart, there's no effect. And there's no point of saturation in the middle at all. You have to bring them in close to that center plate in order to get that saturation. So they didn't even show the distance there. You know what I mean? They just kind of hung it off the ceiling, and I'm going, okay, all right, are we just playing with each other here? I mean, are we going to do something good? You know, because some of us know what effect he's trying to create, and we're looking at it going, you know, fancy lights, it's great. You could be all excited about it. You know, I could do that. I could put a bunch of lights around and then all of a sudden do a camera trick and make myself disappear. That'd be awesome. Maybe I should just do that and I just, you know, screw around like they did. I mean, I don't know.
Yeah, it seems like you know, you understand the science better than they do. You know what I mean?
Well, because we're building it.
Mm-hmm.
That's one of the. That's the main thing here, Mike. We're building it, so of course we know it. We know when you're full of it. You know what I mean? We just point out everything in the world because we've already seen it in the lab.
Yeah, and you can do that. Smaller potentials, what we're working with. You know, like Hutchison. You know, his Tesla coils were working at 4 million electron volts. That's high power, man.
Oh yeah. Well, yeah, you need quite a bit of energy to get that dielectric. That's what I mean. If he had them, if that top one, let's put it this way, if he had 4 feet or 3 feet even at that top coil, and then you say, okay, was the bottom coil underneath it or was it attached to the center to that plate in order to get the saturation? So that you have to decide that as well. So if it's under it like they did it, in order to pull that kind of distance, you're way over millions of volts. Way over that. There's no way to get a dielectric at that distance. You're going to fry the wire on the Tesla coil before you get that energy.
Yeah.
So, yeah, there's no way it worked that way. You cannot use that much energy in there. It'd be even useless. Even if you got the test to work, then your craft that you want to build with it is completely and utterly useless at that point too. I mean, you're just walking into like a death machine.
That's exactly what it is.
Yeah, it's useless.
You might as well just stick your head into the microwave oven.
Yeah.
You know, like that's pretty much what you're doing.
Go in there and do a hula dance or something. You know what I mean? Because it's about what you're going to get.
Yeah.
No, thank you. And I don't think he could have had that much into one of those coils in an apartment building when he had that, because that amount of energy inside of a Tesla coil in an apartment building would be like 3 neighbors over. It would be getting their light bulbs to light up in their house.
Oh yeah,
you know what I mean?
And he said some of his neighbors were saying plates were flying off the table.
Yeah.
So yeah, they thought their house was haunted when it was actually Hutchison making it happen.
And what they didn't take into account for is cavitation. So, you know, once you ground out to the building you're in, the room you're in is creating cavitation. So if you don't understand that about the static electricity and the cavitation, you'll never get it. And that's another reason why I don't think that was going to work.
Yeah.
But again, I'd love to see it work. Don't ever get me wrong, but I just don't have a lot of faith in it.
Well, I think the other thing that made Hutchison's experiment work is his was in a room that was sealed, because basically, in essence, what he was doing is it was a charged gas inside that room.
Yeah,
but
he pressurized it.
He pressurized it, right? And you know, you got all that ozone in there. You don't want to be inside there.
Yeah.
It's
so the whole idea is to pressurize it and create time dilation. And when you create time dilation in a plasmoid in the center, then you're able to get the effect. If you cannot do that, you don't get the effect. That's about as simple as it gets. Those are the things you need. And if you can't create that in that environment, you'll never get it to work. And that's why when he created plasmoids in that way, that the actual bars ripped apart, because he built it, the thing created inside the metal. It didn't create on the outside. It created right dead in the center and just ripped this thing to shreds.
Yep. And that's when he started corresponding with Kenneth Shoulders, because he was doing all the plasmoid technology at that time, right?
Yeah.
the EVOs. So they start collaborating a lot, and they realized, his experiments, what John was doing, they were getting the same effects, just in
Yeah.
a different method. So you can create the same effect with different methods. You just have to know the mechanics of it.
Yeah. Well, yeah, you could say that without saying time dilation, but it would be wrong. You're the only way that these things work is with that. So
Yeah. And that in a rotating magnetic field, I think that's also a very key component
oh
to
yeah,
time dilation.
I absolutely agree with that. But you're going to adjust time when you're doing these experiments. It proves out in the lab. I mean, don't get me wrong. You got a couple minutes difference between clocks. You're gonna have some problems if you don't account for it. But that's the only way to get it to do it. So
Yeah.
yeah.
Yeah. It takes a long time. Some people get it quick and understand it. Some people, it takes years for them to really understand what's going on.
Well, if you build it and you didn't build it to make the effect, but you got the effect and didn't realize the exact parts that got you there, it's
Right.
going to take a lot longer to figure it out. So I think in the beginning, Hutchinson, it took forever. I think towards the end, he probably got it right away.
Yeah. Yeah, exactly. Yeah, it was just, he was fascinated with the stuff in the beginning, didn't understand electricity all that much, and then started replicating Tesla stuff and started building the stuff, and eventually figuring out what he was actually doing over time, right? Gaining experience and knowledge over time, right? That's kind of the way I was too. I got into this knowing absolutely nothing. And over time, I'm starting to learn stuff and putting two and two together and said, that's why that's happening, right? And then find other people out there getting the same effect to confirm what I thought was true.
Yeah.
Right?
So spin and pressure, your room is the pressure. You're pressurizing the room. You're not, yeah, it's not a little area. You're pressurizing the entire room with static electricity, is what you're doing. So the other thing is the spin is you have to have magnetic spin, and that's probably why they tried to light up those bulbs, and they were trying to get the magnetic spin going, but that's the wrong way to do it. The rotation has to be cold. That's correct. It can be hot. You're creating two different types of plasmoids when you're having between hot and cold, by the way. So yeah, I'd prefer cold energy to do it because it's less harmful to you.
Yeah.
You know what I mean? Then
It's
it,
not
and
parasitic.
yeah, it flows easier too. So you can get a heavier value at a lesser amount put in. So you can make that magnetic so much bigger with the least amount of energy. So that's what I would do anyway when I create it. I wouldn't do it in a hot area because then it's
It's
just too
parasitic.
much.
Well, it's parasitic, and you start getting hysteresis and all that stuff, and and then the danger aspect to it as well.
Yeah, that you got to control the temperature. You don't control your temperature in the room, the plasmoids go wherever they want. You have to direct them with temperature.
Yeah.
So, anyway.
So you have two factors, static and heat.
Well, magnetics and static, yeah. So,
Right.
yeah, you need both of those, and then you got to pull the cold side, at least the way I see it. If you pull the hot side out of it, the energy amount you're going to use is much higher.
Yeah. See, like Eric Dollard said, the only way you get electricity is by it's two major components: dielectricity and magnetism. You can't have one without the other. With the two together, that's when you get electricity.
Yeah.
That's what makes electricity.
So, yeah, there's a lot to it, man.
Yeah, like a lot of people referred electricity as like a gas. It flows like a gas. It can consume a room exactly like a gas. You could create pressure with this gas in the room. You can concentrate it. So if you get it really good and you got a really good sealed room, you can create a really, really charged space.
Oh yeah, and quick. That charge moves quick.
Yeah. I found some of the best experiments I did charging the room is actually in the basement
Yeah.
because you're
Oh yeah.
surrounded.
Sound like Gerald now.
Yeah, because you're surrounded by concrete.
Yeah.
Perfect. Right?
Yeah, find an old bunker somewhere. You might be all right. You know what I mean? Pulling the experiments in there, be better.
Yep. Confined space. So, there was a guy years ago. Actually, I heard this story. I believe it was from William Lynn, one of his interviews. He was talking about this guy. He was in the army, and his brother was an experimenter. And at this time, back in the early 90s, he was also in the military as well. Both brothers were in the military. But the one guy, the one younger brother, he was a bit of a techie. So he decided, he lived in Anchorage, Alaska at the time, and he lived in like a shipping container type home. So he took like a high voltage Tesla coil. He totally insulated his whole, container home, so it would trap all the electromagnetic inside. So he had an aerial antenna, and he attached the Tesla coil to the aerial outside. All right. He started getting some very interesting effects. One, he was able to move the mouse on his computer with no mouse.
Huh.
The other one was he was able to move a pencil on the table just by thinking. He was getting telekinesis.
I want to do this. I want to experiment with this. It sounds really, really cool. Like,
Yeah.
Yeah.
So anyways, they came outside to take a look at the container home while it was charged, and they said it looked like it had like a blue corona going around the entire structure.
Oh, that'd be so cool.
Yeah. So so they said, all right, I can move the mouse on the computer with no mouse. I can move a pencil on the table just by thinking about it. How about I think about something, to affect maybe say the weather or whatever. So they all sat together and said, okay, let's think of wind, a big wind, like a windstorm. Within 24 hours, they had the biggest windstorm ever to hit Anchorage, Alaska. It did hundreds of millions of dollars damage to the area. After that experiment, he said he literally took the whole thing apart. He wouldn't touch it ever again.
Wow.
Yeah.
That's insane.
Yeah.
I mean, that's like really, it's insane. But I would have done it one more time just to double check. Like, was it coincidence or was it for real?
No. But the thing was, like, he had like a table, and he basically got 2 drums of water, of seawater. He took the high voltage that was coming from the high voltage supply from the Tesla coil into 1 bottle of water, and then going over to the second bottle of water, and the whole table where those 2 bottles of water were sitting on, he covered the entire table with tin foil. And then he got a wire and connected the table with the tinfoil on it to the ground of the structure of the house, the container home. So now he's isolated, I guess, a ground from that table to the rest of the house. So anything that was on that table, he was able to do telekinesis.
Huh. Oh man, that sounds interesting.
Yeah, it was just if it was real and it really happened, that's a really cool story. Like, that's just fascinating. Yeah.
Well, like your experiments earlier, you can cover your workbench in tinfoil.
Yeah.
And hook it to like the flyback on the negative side. It'll suck down to that entire table and be static electricity field all over it. It'll light up the whole thing.
I think that's what they did with this experiment that he did, because
Oh,
he was also picking up the atmospheric energy because he also hooked it up to the TV aerial on
yeah.
top of the house.
So if you put the negative electricity from the Tesla coil onto that thing right there, by the way, every single jug of water or whatever was around it, if they're glass, they'll be capacitors for it.
That's what it was. That's why
Yeah.
he had the 2 jugs of water, seawater.
It's just interesting how it all works. That's pretty cool. I'm gonna have to try something like that. I'll get some tinfoil. And
I thought about it for so long. I said I got to find a container home and I got to try this.
I don't know about the container home. That might be bad, but I got a big
Maybe
garage
like-
door. I
Or
want to see if I can't light up the garage door.
or even like if like the old metal campers, the old campers.
Yeah.
You could probably do it in that.
Ooh. Yeah. I don't know that I'd want to be in there. Let's get some remotes. Something to turn it on from a distance. Maybe some hard wires.
Man, you guys are talking, and I'm like imagining the possibilities. Thank you for putting it like on like 4 wooden stilts, raise it, not really
Yeah,
touch
it's
the ground.
yeah, and it's got the structure of the house has to be isolated from the ground. It's got to either be on rubber tires
Mhm.
or on blocks. They cannot touch the ground.
Yeah, I was thinking.
Kind of interesting, eh? I would just love just to see that thing glowing, a corona around the whole building. That would have been cool.
Oh, yeah. Well, here's something people don't know. When you deal with the cold electricity, if it's cold outside, the wire itself, when you put your finger along it, it turns blue.
Yes.
So it's positive pressure on negative electricity, where it's negative pressure on positive electricity. So, and that's what brings out your glow. So when you go over and you put this thing into a jar and you put your wire in there, you have to pump pressure into it in order to get the glow to come out of it. Because the dielectric's on the opposite side that it should be. Normally it's on the outside. Well, in cold, it's on the inside. So now you have to pull it differently. It's just interesting because I noticed it when it was outside. It was like 20 degrees Fahrenheit outside, right? Yeah. And I turned on my Tesla coil, put the wire down the center, and I went to go move the wire, and here's this blue glow showing up on the whole wire.
Really, eh? Nice.
Yeah, and I'm going, okay. Now I can see how Tesla turned blue in, his experiment in, where was he at? It was in France when he did it. So, and I don't know that the temperature was that low or anything like that, but I think he figured out what it was based on that, and then he did it. And he knew he had to put some kind of field around himself in order to push that out.
Yeah.
So it's pretty interesting, man. That's something you don't usually see.
See, like this guy did it in Anchorage, Alaska. Now, is the northern latitude a factor? Is that because the North Pole, right?
Oh, and the auroras? Yeah.
Yeah. Maybe he created an aurora around the building.
Oh, yeah. That's probably what it was. That would be pretty cool.
What if when we see UFOs, it's something like that, but on a magnitude, and we're seeing something in the sky, and that's what we think it's UFOs, but really it's a, concentration of energy at, localized point,
Well, I think it's, if it is a spacecraft, then obviously their material science is way superior, that it can harness these energies that are surrounding it. It wouldn't actually need a fuel source on board. It wouldn't need it. It's all around you.
Yeah, well, that container had to be saturated probably for a while with the energy and become completely magnetic.
Yep. And it was isolated from the ground. It was on rubber tires.
Wow, that'd be wild.
Yeah. That's cool. Eh?
Yeah.
Okay. And this happened around 1992. Yeah.
That's interesting.
After that windstorm happened, and the guys just went, "Holy cow, man! What have you made?" And
yeah,
I'm taking the son of a bitch apart. It freaked him out.
Yeah, I don't blame him for that, man. You get something like that, you just kind of take it apart, and walk away.
But question, wouldn't you think scientifically it's Alaska, it's cold, there's going to be windstorms? What if it was just a coincidence?
I don't know. I don't believe in coincidences. I really
Not
don't.
like that.
No, no, that was too major. That was, and it wasn't reported. It wasn't any kind of geological, forecast for something like that to happen.
Okay, so
And
then, right.
literally within 24 hours, that wind event happened. So it was whatever they put in their mind, it became real.
That'd be so awesome, man. You move things with your mind.
Well, I think what it does, it enhances the connection between you and time space.
I know. I think it creates such a huge energy that it restructures the observable universe just by, having a high energy propagation field. Like changes everything. All the
It connects your
polarity.
brain. Yeah, it can connects your brain to the universe.
My
Oh,
God. But you have to have more energy than the ambient chemistry, let's call it, like the outside, where it can alter it. And the smallest way to alter it is charge. Like flipping the charge could alter it into a different.
I think it's just creating a quicker bald rate between you connecting yourself to the universe. You're able to create a better highway of trans because our thoughts become reality. Honestly believe that. But if you have something to accelerate or enhance that effect, because obviously those three guys together, their energy transmitted into the universe and made it happen. Because I don't believe in coincidences like that. It was such
well,
a
it sounds like the same thing that the car device was putting off, and that who was it, Fred?
Oh yeah. The
They,
Otis car. Yeah.
yeah, and then the other guy was talking about it. I forget his name. But he was
Yeah.
describing how it worked and how he used his mind to move the craft and everything.
Mm-hmm.
It sounds like the same thing.
Yep. I think it is too. Now, if he had some kind of crystal in that setup, who knows?
Yeah.
You guys might not believe me, but I promise, I swear on whatever like is the dearest and holiest and whatever to me. There was one point in my life I was able to start a car without the remote control, without the key. Yeah,
That'd
I
be cool.
pushed the starter on the car and it would start. No key. Now tell me that's not some kind of energy field that I was creating.
Yeah.
Yeah.
I would detect a text message coming into my phone before it hit my phone.
Mm. Or I see sometimes like a
Or
blob, like a black, like a darker shade of energy, and then all of a sudden, yeah, my phone rings.
yeah.
Yeah. So I don't know. I think it is possible to
It's
start
part
seeing
of
it.
the it's
And
part of the ESP mind connection to the universe.
Yeah, that's crazy. I love it.
It's
I
all
absolutely
connected.
love it. That'd be
It's
so cool.
it's
I'd be like,
energy.
I'd be testing it out by saying "beer me" and put my hand out. You know what I mean? Like Magneto and getting my beers to me. That'd be awesome.
Yeah.
Nathan, do you think cold energy, if somebody were to wear a device, like a device, let's say on their wrist, could they start electronic things just by touching it by using cold energy? But in a device format where it's actually like that
You
you could
probably
use it.
would damage it first. It all
Mm.
depends. It'd have
Yeah,
to be.
I don't know that they'd be able to be honest with you. Let me think. You'd have to pull the power wires to see if it went first, if they were compatible. But I would imagine you'd put energy into it. It might explode the battery that's in it right away. Um, I'd have to try that. So
Like a, like a
next time I
human
do it,
starter.
I'll
A
take my
human
old phone and hold it, and then I'll put my hand in the water and we'll find out.
like a human starter. You don't need all the little battery operated things. You could start things by just touching them.
Yeah, it's like telekinesis.
Yeah, but
Yeah.
really, yeah, I mean, yes, some people have that supernatural power, but I'm saying if we want to do it as a device that could do that, you know?
Yeah, be really interesting.
Well, okay, I don't know how many people are listening, but that thing that I went to in Austin, you know, like one of the things, if you could create some cool device that, all the departments, military, Navy, Air Force, any, everything that has a, under that umbrella, like if they could use this device, oh, we'll buy it from you. But think about it. Like, that's a cool device, and it can become handy in so many things, like
Hmm.
so many things. Ah,
Yeah, I'm still
Interesting.
thinking about that foil. Sorry, on my table.
Yeah.
Yeah, it was just because my table's right in front of me, so I'm
Yeah.
looking at it.
The big crystal spring water ones, fill up 2 of those with salt water and then
Oh,
connect.
I wanted to take some ball jars and just put them in there on each corner with that stuff in there, and I just want to see the field it creates.
Probably quite a bit because those water bottles is basically like a modified like Leyden jar.
Well, yeah, it's a capacitor. It's like a Leyden jar. Yeah.
Yeah. Yeah.
So I'm sorry. I know you guys talk about other things. I just got it in my head. I can't get it out.
Yeah.
You know what I mean?
That whole experiment that guy did is fascinating. And it's just one of those. I wish I was there. You know what I mean? Just to witness something like that. That'd be really awesome.
Yeah, because if it lights up the foil, man, I'm just going to take big rolls of foil and light it up. And that's like create walkways of foil out in my front yard and start lighting everything up. I mean,
people are going to think you're nuts. Oh, Nathan's lost it now.
you know what's bad? I have like 10 lights, right? And I was over there on the offer up looking up for more lights. And I came across a guy that's got 2-foot black lights. You know what I mean? And I'm thinking that'd be really, really cool to do. So I might buy those. He's got like 30 of them. So I was gonna get that, and then I was looking around for some more fluorescents. So I'm trying to find shorter ones and make it easier, but I might literally light my entire front yard up with lights. Like it's
Like
gonna be
this.
like one of those insane experiments with all the light bulbs on your house.
Yeah, it's going to be like the Griswolds.
Yeah. It'd be like daylight at my house.
Yeah.
do it.
He's gonna be so successful at it, he might light some of the lights next door as well.
The neighbor comes over complaining that all of his lights are on in his house.
Yeah.
It's like, I can't shut them off. Damn it.
Yeah.
Oh, I wonder what kind of field that would create. Oh, that's going to be awesome. I got to try some of that stuff. As long as it resonates, as long as my Tesla coil resonates, man, that energy goes pretty far.
Yeah, it will.
So
they might have poltergeist events in the other houses in your neighborhood.
can you imagine that? It starts up your car just by playing with your tinfoil in your front yard.
Yeah, you just point at your car with your finger and it starts.
Yeah. Then we'd have Lulu's experiments. You know what I mean? Going on with that. Well, she could produce the field. Now I understand it. We'll be able to reproduce this in no time.
But listen, I don't know. Like I'm saying, for a period of time it happened, but I don't know if I could, like, it's possible. I just have to like replicate from everything that I remember from that time, especially, yeah, like I would have to, maybe, I could reach that field again. But, there was once that, was able to do that. And it was, okay, great. I mean, what could you, like, what are you going to tell the world? Like, yeah, I could start a car, without like the keys. Like, I would become a spectacle then,
Yeah.
So, like, sometimes, like, you don't say everything because
If that energy, let me just be honest with everybody here. If that energy is okay at night and I have no problem touching it, I will literally put tinfoil all over myself like a shirt and pants and walk out there and just see what I can't light up as I walk by. I think that would be just so cool. I get my own, you know what I mean? You get your own little hat
You
but,
gotta have the tinfoil hat.
yeah, with the tinfoil hat, and I'll get some tinfoil breeches. I'll just tape them to my pants. You know what I mean? Like on the outside, like Superman. You know what I mean? And then
Just make sure the guys.
we go over, light up light bulb.
Tinfoil necktie.
It's so awesome.
Just make sure.
Oh my god.
Just make sure the guys from the hospital don't come with the white jackets.
It's like, don't take me away. I'm trying to light the neighborhood's and I'm trying to light the neighborhood, damn it.
Oh.
This guy's clearly delusional. They pull you away. I uncovered the secrets of Tesla, damn it.
This has to, we'll put the lights at a certain distance so that you have to be like a certain distance to turn them on, and then we'll just do a boogie dance and see them all go off like strobe lights.
Hey,
Do you want a cooler? Have them line up their cars around and tell them, look, I'm going to start all of your cars. You know?
Yeah, that'd be cool.
You'll light up some Christmas lights.
Oh.
That's gonna be awesome.
The guy will say, "Why is my electric car charging itself?"
Yeah. Oh man, I'm so gonna do that experiment on top of the table. I gotta move some electronics out of the way, and then I still have to try that because I have the Tesla claw. I'll just hook it up. It wouldn't be that hard. And then the tinfoil, you know what I mean?
Oh, I got the thumbnail for you. An AI generated picture of Tesla dressed as Santa Claus.
Oh, nice. Yeah, I sent Ben a thumbnail earlier. I was on Google, and I found out how to switch my Google front page, right? So I put an animated version of us on there. Hey, Mike.
Yeah.
You still there? Let me see
Yep.
if I could show this. I'll just share the screen.
All
Yeah,
right.
that one that you sent me earlier was hilarious. I love it.
Okay. Oh Jesus. Gerald seen that yet?
I don't think so. I sent it to him. That's so funny. Me and Ben are Batman and Robin.
It's too funny.
That is weird.
Yes.
Oh, it's always fun, man, when you can laugh at stuff.
That's
I like all the heads. They just look so funny. All of them are perfect.
well, the heads are bigger than the bodies, right?
Yeah, well, that's on purpose, so you can be funny.
And the expressions are perfect for their poses.
Oh, yeah. Oh, dude, it's hilarious, man. Always got to have a little fun.
Anyways, guys, I'm going to wrap it up here. We've been on almost 2.5 hours. I got to get up early, and who left? Oh, no, that was just your thing. Okay. Yeah, thanks a lot, everybody, for tuning in on the Saturday night. And we'll be doing a live show Friday night this coming up week. That'll be the last show we'll do until after Christmas. So, yeah. Everybody have a great night. Thanks, Nathan, Ben, Lulu, everybody in chat. Chat was great. Thanks a lot, everybody.
Thank you.
Thank you.
Good night.
Take
Thank
care,
you.
guys. Good night.
Have a good night, everybody.
Good night.